Thank you, Senior Planner Ralph, for attending our presentation. We hope that the information provided will encourage you to shift to VMT-based traffic impact analysis. One method to measure congestion is level of service, which tries to capture what a driver feels when they experience delay. As you already know, LOS characterizes delay using a grade from A to F, A being free flow traffic and F being congestion. LOS is calculated with a volume to capacity ratio. The intended goal of LOS was to ensure that travelers can reach their destinations on time with the minimum level of discomfort and inconvenience. LOS was initiated for the development of highways to expand the usage of private cars. LOS is affected by factors such as heterogeneity of traffic, speed regulations, frequency of intersections, the presence of bus stops, on-street parking, roadside commercial activities, and pedestrian activity.
LOS-based TIA requires mitigation measures from developers. This is costly, so developers typically do one of two things. Either build smaller projects to lessen the impact, or move those projects to the urban fringe where congestion is already minimal. This has two major consequences. The first is incentivizing sprawl as developers move farther and farther from the urban core and reinforce the need for cars. But why is this bad? Sprawl generates more driving and, by extension, more congestion. Geographic separation, time spent driving, the physical barriers of car infrastructure, and other symptoms of sprawl limit the connectedness of a community. Good community connectedness has been correlated with healthier behaviors, decreased risk of stress-related illnesses like heart disease, and an overall better quality of life. Sprawl is bad for the environment. Because it increases car dependency, it's also related to increases in air, water, and noise pollution. It also eats up land, whether it's with parking lots or subdivisions, ruining important natural habitats and resources. Traffic mitigation measures are focused on vehicle infrastructure, like adding lanes to a road or installing new traffic signals. This actually increases congestion in the long term. There are two connected principles at play here. Induced demand refers to the idea that as you increase the capacity of a roadway or intersection, you actually attract more vehicles. People switch to this newly improved roadway from different times of day, routes, and modes of travel in a process known as triple convergence. The same idea is illustrated in this diagram. LOS-based mitigation increases the capacity of the roadway and therefore increases the volume of traffic. To actually reduce congestion, it is necessary to switch to VMT-based traffic impact assessments. With VMT-based mitigation efforts, you are improving non-car access to the location, which actually decreases congestion.
LOS is not scientifically accurate. One of the reasons why is because it only assesses car traffic. For example, LOS considers all vehicles equally, whether that be a private car or a bus. However, a bus with 30 people is far less congestion than 30 people in single cars. To conclude, LOS focuses on the performance of a particular line opposed to the conduct of the entire transit network. One example of this is how transit policy focuses on rush hour routes that serve commuters while abandoning quote-unquote inefficient routes that service the entire transit network. In turn, cities are shaped by this layout that prompts sprawl.
The downfalls of LOS-based TIA can be reformed by adopting vehicle miles traveled-based TIA. On the right is a VMT tool that captures the distance between Californians' home and their final destinations. Cities like LA have low VMT based on this tool, indicated by the green color. More suburban or rural areas have higher VMT, indicated by the gray. Vehicle miles traveled is a method of TIA that measures how many miles a vehicle travels from their origin to their final destination. This method allows for more projects to be built in urban environments with walking and transit accessibility because these environments require vehicles to travel less miles. VMT allows planners to help developers build projects in downtown, accessible locations with no extra cost. VMT differs from level of service as LOS measures congestion by capturing delay and often shifts projects from urban areas to the suburban fringe. This poses opposition to urban planning goals. LOS in the city could put planners in a position that causes developers to spend more money on projects, downsize their project, or move their projects to the suburban fringe. On the other hand, VMT in the city does not cause developers to spend more money or downsize. Instead, it favors accessibility, so more transit will be required for a project that initially lacks it, which is beneficial to planning goals and strengthens the relationship between planners and developers. In addition to VMT giving planners the ability to help developers, low-impact VMT is attainable for planners. Researchers Lee and Handy found that in VMT-Based TIA, projects near transit and projects that serve local clientele were projects that would be considered low impact. This categorization is important in furthering the goals of senior planners. Having a low-impact VMT not only saves developers money, this also strengthens the relationship between planners and developers, and it creates convenience and efficiency for the city or town that the planner services. VMT aligns with planning goals, and the Davis, California study is evidence of this. Researchers Lee and Handy conducted a VMT-based traffic impact analysis of a project that built a target on a previously undeveloped area and compared that to an LOS-based TIA. The results? LOS required developers to pay out of pocket to add or alter lanes and traffic lights. This could cause a strained relationship between planners and developers and opposes the goals of senior planners by making livability more difficult for their city dwellers. Under VMT, the target is locally serving retail, so it does not impact vehicle miles traveled. It would actually shorten shopping trips for locals and prevent developers from paying for mitigation that LOS would require, both outcomes of benefit to planners. This project occurred under LOS, and the result of that is traffic mitigation that makes this target harder to access for locals and easier to access by car, as you can see in the image at the top. On the bottom, you can see what the project could have looked like under VMT.